Recall that the number line is a picture that represents all the numbers in order. Since fractions are numbers, we should be able to put fractions on the number line as well. In this section, we will begin to make the connections to understand how this works. We are going to arrange the pictures of fractions using parts of a whole in order based on the number of wedges that are shaded in. We'll start by looking at pictures using fifths. Notice the number of wedges being shaded in increases as we move from left to right. Also notice that after we get past one whole, we introduce a second circle to help us keep track of all the wedges. Next, we will label these pictures as fractions and as mixed numbers. 0, 1/5, 2/5, 3/5, 4/5, and 5/5, which we will write as 1. And the process continues with mixed numbers as we go past 1, 1 1/5, 1 2/5, 1 3/5, 1 4/5, and then 2. On a number line, we already know the locations of the numbers 0, 1, and 2. The fractions give us values in between these integers, and they follow the simple counting pattern we've just done. In this case, the spacing between the dots is 1/5. This is the same idea we used when we counted by 5s and 10s to do addition and subtraction on the number line, except now we're making the spacing smaller instead of larger. We can also use other spacings using a different denominator. Notice that when the spacing between the integers is drawn the same size, the spacing between different denominators is different. This is related to the fact that wedges are different sizes for different denominators. It's important when indicating fractions on the number line that you draw the markings for all the fractions between the integers. This way, you can immediately tell what denominator is being used in the picture. Example, locate 2/3, 3 1/4, and 1 2/5 on a number line. First, we will draw a number line including only the integers. And then we will work with each number in order. The fraction 2/3 is between 0 and 1, and we need to break the interval into 3 parts. The first mark is 1/3, and the second mark is 2/3. The number 3 1/4 is between 3 and 4. The denominator tells us we need to break this into 4 equal parts, and 3 1/4 is at the first mark. The number 1 2/5 is between 1 and 2. The denominator tells us we need to break this into 5 equal parts, and 1 2/5 is at the second mark. Try your best to make the spacing as even as possible. This will help build your intuition. Also, notice that drawing the markings for all the fractions between the integers makes it clear what denominator is being used for that part. Negative fractions behave similarly to negative integers. You get more negative as you move to the left. An important skill to have is the ability to switch back and forth between improper fractions and mixed numbers. We have seen how to do this with parts of a whole, but it's also important to understand the symbolic expression of these ideas. Example, rewrite 13/4 as a mixed number. We will use the pictures to ground our ideas. Let's start by looking at a picture of 13/4. What did we do here? We had 13 wedges and we made groups of 4. This is a division problem. So instead of drawing circles, we can line them up on a grid, just like we did the first time we did division. When drawn like this, we can see that we have 3 groups with 1 left over. This means we can symbolically represent this calculation using an idea that we used for division. When we were doing division before, we would break 13 into 12 plus 1. And we can do the same thing here, except do it in fraction notation. And now we can complete the calculation using the distributive property to get 3 1/4. This calculation exactly reflects what we did with division before. If we do a side-by-side comparison of the calculation we did before, we can see we're doing the exact same thing. We also need to go the other direction and turn mixed numbers into improper fractions. Example, write 4 3/5 as an improper fraction. Just as in the previous example, we will start by looking at pictures using parts of a whole. And now we'll break the wholes into fifths. We can count out the individual wedges, but we can also think about how this information can be organized in a useful way so that we don't have to count. Each hole turns into 5 wedges. Since we have 4 holes, this means we get 4 times 5 wedges from that part. Plus, we have the remaining 3 wedges. We will now write out this calculation using fractions. 4 3/5 is equal to 4 times 5 plus 3/5, which is 20 plus 3/5, which is 23/5. Over time, you should be able to do both of these calculations mentally. However, in this section, you will be expected to write things out as we've done here.